I would love to introduce you all. I would like to get your introduction as well, but I doubt we'll have the time to do that. So here is my quick introduction. My name is Bharani Kumar, and I happen to be director of 360DigiTMG, which is Digital Transformation Management and Governance. This is how we have renamed our company so as to reflect on what is the industry trend currently. I am into the space of digital transformation, industrial revolution, right? And I also happen to be director of another firm called Innodatatics. Overall, I have 15 plus years of experience, and I happen to be alumnus of Indian School of Business and Indian Institute of Technology, Hyderabad. I have 8 plus years of extensive experience in training. Training is my passion, no doubt about that. But 70% of my time I spend on business development and doing consulting for various companies. And 30% of my time I am putting effort into trainings. Yep, so hope you all are able to hear me. Can you guys resort to chat window? All right, thank you so much for that quick response. Okay, so until now probably I would have delivered 40 plus big data analytics, including AI and all of those, and I would have trained 4,000 plus professionals across the globe by now. Having said this, these are the bunch of certifications which I have into the space of project management, agile. I'm a Tableau certified associate, risk management professional, so on and so forth. Yeah, so this is what I do. It's a very boring stuff, right? So, but I still stick to adding 1 or 2 certificates every year. These are bunch of companies that I work with. I started off working with HSBC, then I joined Indian Tobacco Corporation, then I worked with Infosys, and the last company with which I worked as an employee was with Deloitte. I happen to be a chief data scientist for Athena Technologies, MedliMed, Brontobet Analytics, and Sixbiz, which is a Malaysian-based firm. I happen to be a visiting faculty for Watson Business School as well. So that's in short about my boring profile. I can speak more. I'm known to blow my trumpet, so it will take a lot of time if I start doing that. Anyways, so let's get started. Today's webinar is all about understanding the cost functions in the space of artificial intelligence. Cost function is also called as error function. So let me write it down here. Cost functions are also called as error functions or loss functions. Cost functions are also called as error functions or loss functions. You need to remember that because people fancy using terminologies which people do not know. But cost function is nothing but a simple error function or a loss function. Even before we proceed further, I think it warrants us to understand on what is this artificial intelligence all about. So if I were to give you an onion peel kind of an approach or explanation, I would say that this big onion, onion is now extremely expensive in India, right? So it makes sense to give such an example is what I believe, right? So AI, this is AI. And within that, you have another onion peel, which is nothing but your data science. Within that, you have another peel, which is nothing but data mining. Within that, you have another peel, which is nothing but machine learning. Within that, you have another peel, which is nothing but deep learning neural network. Nowadays, people are using deep learning algorithms to build AI applications. A few of the people are using machine learning, the shallow models, not the deep learning models, the shallow models to build AI applications also, but majorly neural network, which is synonymous to deep learning, is used to build AI applications. Okay, what is artificial intelligence in the first place? The name itself says, right, that intelligence which is artificial in nature. On the other side of the spectrum, you have human intelligence. If you can incorporate human intelligence into a system, that would be called as artificial intelligence. Well, I can give you a classic example pertaining to that. Oh, yeah, you guys would be getting the session, don't you worry. Yeah, I will request you all to just focus and do nothing. So, yeah, here we go. So, if you visit our website 360DigiTMG, of course, we are coming up with domain analytics. The idea is not to sell this concept to you guys, but the idea is to show you this AI-driven chatbot which we have incorporated, right, which we have built. So, it's roughly 7 p.m. None of our team members work on Sundays, but let me start doing the details. Now, who is chatting with me? It is a chatbot, the way a human responds. Many people speak about chatbot, but I haven't seen a lot of people build one, but we have done that, right? So there is a program called as Jumpstart also, which I'm going to speak sure about that in a while from now. Say I'm a working professional, regular courses, say data science. This is the training in Malaysia. So if you were to book a slot, since I'm connecting from Malaysia, this would automatically change. Okay, let me complete that. Let me say I want to book an appointment for 9. On Saturdays and Sundays, it doesn't allow me to book. Because, okay, 9 p.m. It's confirmed. No, I'm good, thank you. Awesome. Yeah, that's the feedback that you leave. All right. So here I can actually change to Malaysia as well. And then it's going to redirect me to another page. All right, perfect. So it got changed. All right. So chatbot is a classic example of how to build an artificial intelligence application. That means, what did we just do? We have replaced the human intelligence artificially with some other intelligence, which is artificial intelligence in some sense, right? If you can build in the human intelligence into a system, that's artificial intelligence for people who are not aware of that. Okay, let's move on. So here is today's agenda. We will understand about cost functions or error functions or loss functions, primer basically. When I say primer, basics 101 foundation kind of. Then what if you have an output variable which is continuous? How do you actually measure the error? What if your output variable is discrete in nature and binary? Then how would you do that? What if your output variable is discrete and if it has multiple categories? How do you measure the error? Finally, entropy and then cross entropy. This is all that we are going to discuss. All right. So even before that, you guys must be aware of the data types. If not, let me do a recap. Continuous variables are those variables which can be represented in decimal format. Any variable which can be represented in decimal format is continuous. For example, if you ask me on what is your weight, I would say it's 79 kgs. You would say, all right. If I say my weight is 79.4 kgs, you'd still say, wow. If I say my weight is 79.41 kgs, you'll say, all right. So even if I represent my weight in decimal format, you're okay with that. It is permissible. It is acceptable. If it is acceptable, that's continuous data. Then discrete. Discrete data is that data which cannot be represented in decimal format. For example, I'll give a basic example of, say, car. If I say I have 1.75 cars, you'd say, hey, this guy has gone mad, right? If I say I have 1.1 girlfriends, then you'll say, how crazy is this number, right? So I'm giving a wrong example. Anyways, so if you represent something in decimal format, and if it does not make sense, then it is discrete data. So you cannot represent discrete data in decimal format. You either say you have 2 cars or 3 cars. Decimals does not make sense. Will an employee resign or not? Accrete or not? Binary, 2 classes, whether the person will accrete or not accrete. Will a customer churn or not churn? 2 classes, binary. Will a person claim insurance policy or not? Binary. Does a tumor have cancer or not? Binary. Will a patient get readmitted to the hospital or not? Binary, right? So all those are binary classes. In discrete, you also have multiple categories. Will an employee pay, will a customer who has taken the loan pay on time, or will they pay with a delay, or will they default? Does the customer who just entered the showroom, say Lamborghini showroom, will that customer purchase a red color Lamborghini or a blue color or yellow color? Color doesn't have any sequence as such, but it's multiple, right? So you will have in the real world either continuous output or a discrete output, binary, or discrete output multiple. Of course, you also have count, but count data can be treated as continuous in some sense. And we are also going to discuss about entropy and cross entropy, which is also a kind of error. It is also a kind of error function, right? So this is the agenda, folks. Cost functions primer, machine learning primer. For those of you who are not aware, I'm sensing it will serve as a good starting point. In order to do data analytics or data science or artificial intelligence applications, you need data. You need historical data. You need past data. Once you have the data, how would the data look like? If at all, you want to build machine learning algorithm or predictive models, then you need to have historical data which has output variable and input variables. Let's take a good example, since you guys have pulled out your time on a weekend. Say you want to predict on what will be your salary given your age, given your years of experience, given that you have undergone data science training, given that you have also worked on a live project. Given all these input variables, we need to predict salary of a person. Okay, and say you have roughly 10,000 observations or 1 lakh observations, doesn't matter. Okay, in order to build this algorithm. So what you do is basically you first split the data into training and test. Forget about validation for now. We're going to split the data into training data and test data. Usually people split the data into 80% and 20%. So randomly you take 80% of your data and put it into training. Randomly, you do a random split. So random split means this is how it would happen. You have output variable 1, 2, 3, 4 inputs, right? So you have your output 1, 2, 3, 4 inputs. And since you're randomly choosing maybe the third row, fifth row, then the ninth row, so on and so forth, you will have all these entries. And if you count on the number of records or observations, 1, 2, 3, 4, you would have roughly 80,000 observations, because 80% of data, 80% of 100,000, you're taking it randomly. And the remaining data would be part of your test. So let me also draw it here. Guys, this is machine learning primer for y'all. Okay, so if you listen carefully, everything will fall in line for you guys. Okay, then. So here, when you have randomly taken data into training, the remaining observations, 1 and 2 are not there. So it'll be part of your test. 4. Then 6, 7, 8. In that way, if you count the number of records, 1, 2, 3, 4, 5, 6, in that way, you would have 20,000 observations in this, because 20% of the data would be part of your test. Now what do? We build the model. We build that. One second. Yeah, sorry about that. Okay, so then you build a model. Say you're building a linear regression model, right? So what you do is, when you build the model, all your machine learning model, any of your machine learning models or predictive models, do exactly the same thing. It just establishes the mathematical relationship between output and input variables. It establishes the patterns. Hey, given age as 33 years, given that you have 8 years of experience, given that you have completed your data science training, given that you have done your live project, what will be the salary, right? So your model looks at establishing the patterns between your output variable and your input variables. And then it comes up with such an equation, because it's linear regression. It comes up with such an equation. Okay, then this equation is the model that you have built. And what did your model learn? It learned these beta values. Your model has just learned these beta values mathematically, right? That is what is the meaning of building model, building prediction model, right? All right. Once you have this, you test this equation or this model that you build on the test data. So what you do now is, you take all the inputs, only the inputs, mind you, only the inputs. Take all of these inputs and then substitute in this equation. The moment you substitute in this equation, you get predicted value. some number, some salary. However, you also have the actual value here. This is historical data. Already I have the data of all the participants who have undergone the training, done the live project, their age, years of experience, assume. And I know their salaries. Okay. So already we have the data. So you take this actual value and subtract these two. When you subtract the predicted value and actual value, all you get is error or loss or cost. Okay, then take the second row, take all the input values, substitute in this equation, and then you get the predicted value. Then take the actual value here and subtract the predicted value with actual value, you get again error. In that way, you're going to get 20,000 errors. 20,000 errors. Take all those 20,000 errors and take a simple average of that, and then you will get mean error for test data. Simple. And then this model that you built using your training data, test it on your training data. Test it on your training data also. Okay, a few of you all might say, hey, we built the model using this training data. So don't you think it has to work well, or it will be predicting exactly the same numbers? Answer is no. It is just establishing the generic mathematical relationship between output and inputs. Generic, not specific. So it will not exactly predict the exact value. So what you do now is you go to the first row, take all these inputs, substitute in this equation, and then you get a predicted value. Take the actual value, subtract these two, you get error. So go to the second row, take all the inputs, substitute in this equation, you get the predicted value, subtract it from the actual value, and then you get error. In this way, how many error values will you get? 80,000 error values. Take average of all these errors, that's the mean error, and this is the training mean error. Usually people compare training and test error to look at whether there is variance or bias, etc. All these would be explained. What is validation data? What do you mean by test? What do you mean by variance, bias? How do we counter it? What is regularization parameter? For all of these things, we are going to have another session, another webinar, right? Which will be for 4 hours. That's called as project management primer. Okay, so just hold on until then. But are you guys clear with what is an error? What do you mean by an error? Or is there any doubt at all? Okay. So all I'm saying is you take your historical data and split your data into training and test, do it randomly. Say I take 10,000 entries, 80% of data randomly I'll take into training. When you do it randomly, it will not do sequentially, right? When I say random, I mean it. So randomly it picks up, say it picked up the 3rd row, 5th row, 9th row, so on and so forth. If you count, there'll be 8,000 entries here. Remaining data will be part of your training. Validation will be explained in the next webinar. In this webinar, we are not going to deep dive into those aspects. We'll just understand what is error function or cost function or a loss function. All right, you'll be notified. You'll be notified about the next webinar, which will be for 4 hours, about entire project management, methodology of handling data science projects. So whatever has been left out here would be part of your testing data. Okay, here you'll have 2000 records because 20% of the data you have randomly split. Any doubts on this part, friends? Sure. Any doubts on this? On splitting the data into training and test? Perfect. Sure. I'm waiting for you to respond. No, all right. So what I'm saying is, when you build a model using this training data, it is going to establish the mathematical relationship between y and x. And if I build a linear regression model, then this is how it will appear. Okay, this is how your model will appear. All I'm saying is take your model and test on the test data. So go to your test data, take all these inputs, substitute in this equation, and when you solve it, you will get some number, some value. Call that as y hat. All the predicted values will have a hat on the top. Okay, and then take this actual value, then subtract these two. When you subtract the predicted value and actual value, you get error. Right? In that way, how many errors would you get? 2000 errors, because all these 2000 entries, you pass it through this equation, you get the predicted value, subtract it with the actual value. Is this part also clear? Is this clear to everyone so that I might move on? All right. So you'll get 2000 errors. Take all those 2000 errors, take an average of that. That's called as mean error for test data. So you'll get test mean error. Then all I'm saying is go to this equation and test your training data also. That means take your inputs and substitute in the same equation. You'll get some number that is called as predicted value. Okay, but here you also have the actual value. Take that actual value and subtract the predicted value from actual value, and then you get error. In this way, how many errors will you get? Because you need to pass 8000 records through your equation. You will get 8000 errors, and then that's called as training error. Good. All right. Yep. Good. I really appreciate when people ask questions. That means you're listening, right? If you don't answer, then that's a challenge. Okay. By the way, guys, just out of the box, we have our learning management system, which is live now, which is called as AI Sprite. And what we have done in this AI Sprite is, we are still coming up with that. Food for thought for everyone. And also I'm open to take your suggestions. So what we are doing here is, in AI Sprite, we have come up with a chatbot. So what happens is this very webinar would be recorded and it will be placed on a learning management system. You can log in with your username and password, and then you'll be able to view the video. On that video, if you have any doubts, say Shaw has asked me a question on, hey, what is the training error? So in the recorded video, whom would you ask the question? However, we have built a chatbot. All you can do is you can post your question here, and the chatbot would automatically respond to you. How would it respond? It would get trained on the video. Video would get converted to speech, speech to text, And we have done natural language processing and RNN, LSTM, deep bidirectional LSTM, etc. on the data. So it's going to respond. But if you're a lazy bum like me, then there is a speech option. It'll be speech enabled. So you can just ask your question. The moment you ask a question, the video will pause, and then it's going to respond back on your query. Exactly the way a tutor would do. This also helps the visually challenged people. And my objective is not to leave behind those people who are unfortunate. Okay, just because they do not have eyes does not mean they should be left behind, right? So that's one thing. Second, should we leave behind tier 2 and tier 3 cities where people are not very good at in speaking English? We have 33 franchisee centers across India. And I know that a lot of students are unable to understand English well. So even if they speak in their own language, our chatbot should have the capability to respond. That's language translator. Of course, from business perspective, we can target Chinese market, German, French, etc. The third thing is behavioral analytics. That means when you play a video, your webcam will get switched on and it will capture your facial expressions. And if you fall asleep, it is going to give a big knocking sound on the screen, right? So that you wake up and come back to the subject. That's the third part of our learning management system, behavioral analytics. At the end of watching, say, 2 hours video, you will get a report card, like your kids get report card, right? You also get report card. It says, congratulations on completing 2 hours of video. However, you were physically present and mentally absent for roughly 40 minutes, right? It gives such reports. And then it will say, do you want to know? Then click on that. Then it will say, okay, from 40th minute until 52nd minute, you were unattentive. You were also unattentive from 1 hour 03 minutes until 1 hour 08 minutes. Do you want to watch only that clip? Click on this. You'll go there. And the final thing, which we are yet to build, yet to even devise tech architecture, is augmented reality. Within augmented reality, rather than you seeing a chatbot window here, you will see my face until my torso. And when you ask a question, it will appear as if I am physically responding to you. These are the capabilities that we are building. Already with respect to text and speech, we are good. Language translators, we are trying to see how to leverage the existing APIs. Behavioral analytics, yeah, work is, I would say, 20% done. Another 80% is pending. This is a distant dream. So that's what our, chatbot is all about. Yes. Thank you. Not yet. Not yet. We have approached, rather, a few people approached us for funding this particular project, but really, we are contemplating on how it works out. Anyways, yeah. So I just wanted to keep you guys posted on what we are doing from our end. All right. Now, if the output variable is continuous, then how do you calculate error or cost or loss function? So I'll give examples, right? Say you're using two different models, model 1 and model 2. It could be any model. Say you have used some kind of a KNN model or some kind of probably knife base or some model basically, right? Using first model, you predicted that you'll be selling 101, say, mobile phones. But actually you ended up selling only 100. And predicted minus actual is error. For the second month, you predicted that you would sell 199 mobile phones, but you have actually sold only 200. When you subtract, you get -1. And when you predicted for the third month, you predicted that you would sell 301 mobile phones, but you sold only 300. Predicted minus actual is error. So in that way, you got all these 4 errors. When I take average of these numbers, these errors, you add them and divide by 4, simple average, and then you get a mean error, which is 0. Look at model 2. It predicted that you would sell 110 mobile phones. On contrary, you sold only 100. So the difference between predicted and actual is error. So for the second month, predicted value minus the actual value is error. Predicted minus actual value, error. When you take average of all these errors, you get 0. If I only expose you to mean error, and if I ask you to tell me on which model is the best, model 1 or model 2, which one would you choose? You would say, hey, both the models have 0 errors, so both are same models, or both models' performance is the same. However, when you dig deep into the data, you would find that model 1 is the best. Right? However, when you look at mean error, it gives you a false impression that both these models are the same. To counter this problem, people have come up with different ways, and they thought, can we not simply take absolute value of all these errors? Absolute value of all these errors, then negative value would become positive. Now, if you take absolute deviation between predicted and actual value, deviation, take the absolute value and take an average of that, then you get 1 here and 10. If you're exposed to MAD means mean absolute deviation, right? You would say model 1 is the best. Then a few people thought, hey, why do I need to take modulus? Can I not take square? Now, a lot of people ask me this question on, hey, what is the difference between modulus and square? Right? Why do we need to always have modulus? Okay. You can also have squared. Square will actually maximize your error and then show it to you. It's kind of, it's going to exaggerate. When you square your errors of 10, you get 100. So that means you're exaggerating. Bad things have to be exaggerated in some sense, right? Yeah, that's one reason. Another reason, it's good for various integrations and all that. But nevertheless, so you take the error values, square those error values, and then take an average. You get 1 here. When you square these values, you get 100 throughout and 100. By looking at the mean squared error, if I ask you on which model is the best, you would say model 1 because it has the least error. Now, the challenge is if you have these, say these are salaries of people in dollars per day or per hour, then you'll get dollars, right? If this is $101 and $100, if you subtract, you get $1. So you get everything in dollars. You get everything in dollars, right? Then if you take these errors and square these errors, you get how much? $1 squared, $1 squared, $1 squared, and $1 squared. Here also you'll get $100 squared if you square these. And then when you take an average, you get $1 squared, and here you get $100 squared. Units does not make sense. So how do you get rid of that? Simple. Take a root of that. That's called as root mean squared error. Then you get back your original units. By looking at root mean square error, you know that model 1 is the best. But there is yet another challenge with the root mean squared error also. What is that? Say, the people who have built this model 1 have used dollars. So you get $1 throughout. So root mean square error will be $1. Say there was another team which has built exactly the same model on the same data, But the only thing is they converted US dollars to Indian rupees. So $1 is equal to 70 rupees approximately. So you get 70 as error. Say this team is in US and this team sits in India. So they, for some reason, strange reason, change the units from dollars to rupees. When your management asks on what is the error to the US team says error is 1. When they ask the same question to Indian team, they would say error is 70. Now the management would be biased, right? They would say that, do you know what? Our folks in US have built a model, error is 1. The folks back there in India haven't done a good job. They're saying error is 70. Misleading the discussion because of units, right? If you don't want units to influence your error values in this way, then it is always better to represent error in percentage terms. So all you do is error divided by the actual value. Error divided by the actual value. Error divided by the actual value, that's 1 upon 100, minus 1 upon 200, and 1 upon 300, and minus 1 upon 400. When you take an average of these values, you get something called as mean percentage error. And it's 1 by 100. Say here it was 100. So what would you get? Minus 1 by 100. Say here it's 1 by 300. And what if this is also 300? It become minus 1 by 300. When you take an average of these numbers, these get cancelled out and you get 0. To avoid such a problem, you take absolute value of your percentage error. Even if this is 100, assume that this is 300. When you take absolute value of these errors and then take an average, that is called as mean absolute percentage error. So you're taking the percentage error, taking an absolute value of that and taking an average of that, right? So in the real world that we live in, MAPE is the best way to move further, not even RMSE, MAPE, right? I would always bank on that. Then I'll look at your chat window in just a moment after I explain this. The relationship between error and accuracy is as follows. Error percentage, if I say is 3%, then you know that it's 97% accurate. When you add these two, you get 100%. That's the relationship. Accuracy percentage plus error percentage is 100%. Or you can equate it to 1. If the error is 0.03, then you will say, hey, accuracy is 0.97. So together it will sum up to 1, right? So if you know error, you just can calculate accuracy. On the contrary, if you know accuracy, you can also calculate error. Now let me look at your chart. No, not exactly. Sam's question is, isn't root mean squared error exactly similar to MAP? No, not at all. Okay. You can try out mathematically, you can just try out with different numbers. You then understand that it's not the same. All right. So now, what if your output variable is binary or discrete rather? If your output variable is discrete, we make use of something called as confusion matrix. Confusion matrix. Let me explain this in the simplest of the way. So, say you're predicting on whether a patient has disease or not. If the patient has disease, you call it as positive case. If a person does not have disease, then it's a negative case. For example, if someone says you're tested positive for dengue or you're tested positive for swine flu, that means you have disease. If they say no, it's negative, then there is no disease, nothing to worry about. Okay. Then you have predicted values and actual values. If you have predicted the positive case correctly, disease present is positive, disease absent is negative, right? So this is a positive case, disease present. So if you are correctly predicting that there is disease, the positive case, then it's true positive. Positive case is disease present, true means correct prediction. True is correct prediction, false is incorrect prediction. Simple. Then true negative. True means you have correctly predicted what? The negative case, not having a disease. That's true negative. False means incorrect. So here you have incorrectly predicted what case? Positive case. False positive. Then you also have false negative. That means you have incorrectly predicted a case as negative. That's false negative. If you look at this, true is a right prediction, false is a wrong prediction. So by looking at this, if you were to calculate the error or accuracy rather, you just sum up this diagonal and say that true positive plus true negative are the correct predictions out of overall predictions. So true positive plus false negative plus true negative. When you do this, you get accuracy. And 1 minus this is error. Or if you want error on the other side, if you say no, not accuracy, I want to calculate error, then simple. You take the incorrect cases, which is false positive plus false negative, upon overall predictions. How many times did we incorrectly predict out of overall predictions? So you have to put overall predictions also. Okay, this is error. If you know error, accuracy is nothing but 1 minus error. The thumb rule is that when you calculate accuracy, if the accuracy is greater than majority class, that means say you have historical data wherein the output variable is whether the patient has disease or not, and you have various inputs as well. And here in this data you have say 10,000 records. Out of 10,000, say 9,000 records say that patient does not have disease, and another 1,000 says patient has disease. So what is the majority class here? Anyone? What is the majority class?
No.
Exactly, no. And what percentage of no do we have here? Hey, where did that go? 90. So your accuracy when you build your model should be greater than 90%. Hope that is making sense. All right, now let's move on. There is a thin line of difference between an experienced data scientist or an analytical data scientist rather versus non-analytical data scientist. Wow, this could be a blog topic, right? I just made out something. Okay, so the reason why I'm saying that is because say your accuracy rate is 98%. Yeah, you clap hands, hug each other, and then you release the model in the market. However, So what also happens here is, one second. So here, if at all there is a positive case, right? False negative and false positive. Positive means person has, you have incorrectly predicted. You have incorrectly predicted that a patient has cancer or disease, right? Here, false positive. If you predict incorrectly that a patient has disease, then after a few days or few months, patient will come to know that patient does not have any disease. They'll be happy or probably even happier. But if you look at false negative, that means you have incorrectly predicted that a patient does not have disease, while the patient actually has disease. Say the patient has cancer and you predicted no cancer. Then what will happen to the patient? Patient will die. So the false negative case is very dangerous. Overall, your accuracy might be wonderful, but maybe the 2% error is here. And here say you don't have any error. This model is very dangerous because for a patient who has cancer, the model has 2% risk of classifying that the patient does not have cancer. Very risky. But your overall accuracy does not capture such things. If you want your overall accuracy to capture such things, then you have to look into a few other metrics such as F1 measure, etc. Okay, so let's look at those now. And before that, do you have any questions? Yep. Right, folks. How to derive the best threshold value? What do you mean by that? What do you mean by threshold value here? I didn't get that, Sean. Okay, while you get back to me on that, I'll just proceed on this, right? So you can measure something called as precision. Precision is probability of correctly identifying a random patient with disease as having disease. If a patient has disease, you have to predict that a patient has disease. That's precision. Then you have sensitivity, which is also called as recall or hit rate or true positive rate. This is proportion of people with disease who are correctly identified as having disease. Here, randomly, if I choose a person, what is the probability that that person has disease? Here, overall, what proportion of people with disease are correctly identified as having disease? So the formula varies thinly. There is a thin difference here. Here you use false positive, here you use false negative. True positive by predicted positive. How many cases did you predict positive? Out of that, how many are actually positive? But in sensitivity, you take all the positive cases and how many times did you correctly predict? Right? That's sensitivity or recall, etc. There is PR curve or precision recall curve, etc., right, which people make use of. Then you have specificity, which is true negative rate. Proportion of people with no disease being characterized as not having disease, simple. So take all of your actual negative cases, that is this disease not present, actually not present, these two. And how many times did you correctly predict that? Then there is something called as FP ratio, FP rate, false positive rate, which is nothing but alpha or type 1 error. A few of you all were saying alpha error, type 1 error. Yep, that is what this is. It's 1 minus specificity. Then you have false negative rate, which is called as beta error or type 2 error. That's 1 minus sensitivity. And then you have F1 ratio. Usually people look at F1 ratio or sensitivity, specificity, or recall precision curve, etc. It's a harmonic mean of precision and recall. It ranges from 1 to 0, and if it's somewhere in between, that means you are balancing out both precision and recall. Questions. Okay, based on scenario like nuclear classification or cancer, etc. I mean, I'm reading out question from Nicole. Must have accurate without false negative, or what is this? Tinest. Okay. I'm not sure I quite got you. Okay, true positive is predicted class, true positive is actual class. Yes, yes, yes. All right. Okay, answer to your question. I know that true negative is actually class. All right, guys. Fine, let's move on. Then we have something called as ROC curve, which is receiver operating characteristic, right? ROC, receiver operating characteristic curve. You know, this curve came into existence in World War II. People were actually sending false alarms saying that, hey, we are going to attack you, we are going to bombard your harbor, we are going to drop bombs on you, etc. And then your armed forces would actually be protecting that region while the enemy is going to, attack a different location altogether. So people wanted to somehow differentiate between the true signals and false alarms. That has given rise to ROC curve. I mean, majority of the models, statistics, maths, and the techniques that we're using now came into existence because of World War II. Now I just sit back and think about what if there wasn't World War II, right? So, anyways, so here you look at false positive rate, and here you look at true positive rate, and you look at both. This is 1 minus specificity, this is sensitivity. And if you look at this curve, this is called as classifier with no predictive value. That means false positive rate is also 20%, true positive rate also is 20%. False positive rate is also 40, this is also 40, true positive rate. I mean, it cannot happen in that way, right? So this is a line which has absolutely no value. And what do you want? You want the true positive rate always to be 100%. I mean, always you want right predictions, and false predictions, you always want that to be 0. And that's this red dotted line, right? Always you want your true positive rate to be 100%. That's the perfect classifier, right? And then this line, right, classifier with no predictive value, can be thought about as tossing a coin. I toss a coin. If it is head, patient has cancer. If it is tail, patient doesn't have cancer. It completely depends on whether you get a head or a tail, right? All right. Then your model that you build will, you actually strive to get to perfect classifier, but you would not always get there. You'll fall somewhere in between the perfect classifier and classifier with no predicted value. It'll lie somewhere in between. All right. Now, the more the region under this curve, better is your model. Simple. And one more thing is, you can also come up with cutoff point. Wherever you see a bend, this is okay, but sometimes your curve will be like this, right? So here there is a steep bend. If you draw a tangent there, you'll have a value here, right? Say it's 70% or 75%. So you say that my cutoff point will be 75%. What does that mean? When you build your logistic regression model or any models which give probabilities as output, then usually what happens is you say that if the probability is greater than 50%, that's a cancer case. If the probability is less than or equal to 50%, that is a no cancer case. So here, in cancer and no cancer case, sometimes people want to choose a different number. Why 0.5? Why midway? They want to choose some other value, right? So here, when you draw tangent, you get 75%, right? So you change this to 0.75. So this is also used to come up with such a cutoff value also. All right. Now, if the area under this curve that you're seeing is 90% to 0.1%, then your model is outstanding. If the area under the curve value lies between 80 and 90, it's excellent. 70 to 80, acceptable. 60 to 0.7, poor. 0.5 to 0.6, that means it's unable to discriminate between cancer and no cancer. It's a false, I mean, it's F, fail case, right? So this is about your ROC curve. Then you have multiple categories. Before that, any questions, folks, at this point of time? Do you have any questions? Nope. All right. So if you have multi-class problem, such as a video, right? If you have a video, then usually what happens is video, by looking at that, you need to predict on what's happening in the video. You need to predict on what is happening in the video. So is a person bending? Is a person jacking, jumping, running, so on and so forth? So if you look at this, this is also confusion matrix, an extension of confusion matrix. And confusion matrix is also called as cross table calculation. So here, if you look at jumping, 89% of the jumping cases have been accurately predicted as jumping, and the 11 cases of jumping were classified as skipping, incorrect. So if you look at this diagonal, you have the correct predictions, right? So this is how you calculate the accuracy when it comes to multiple categories. One more thing is, okay, I'll get back. I'll get back to that. I think there is a question from one of a friend. I think today, unfortunately, there is also a cricket match, so people must be busy watching the cricket match. So I'll do one thing. I will explain about these things, and then I'll halt, and we can tomorrow at same time, or we'll notify you on when we can discuss about entropy, information gain, and cross entropy. Okay. All right. Let's focus on this. This part also I'll explain later. Misclassification error. But one of a friend had a question on, can you explain this probability part? Okay. Usually, when you want to build a, say, logistic regression model, for example, and you want to predict whether a person has cancer or not. So when the probability values are greater than 0.5, you say that patient has cancer. If the probability values are less than 0.5, you say that patient does not have cancer, no cancer. You take a midpoint, right? You strike a right balance, 50%. However, 50% need not always be right. So what do you do then? So what happens is, if this blue curve that you're seeing here is, say, like this, or something of that kind, right? So then what happens is, you just draw a tangent. Wherever there is a bend, you draw a tangent. and see what is that percentage. Say this percentage is 78%. So instead of 0.5, you will change that to 0.78 because you got 78 there. So probability greater than 0.78 means cancer. Probability less than or equal to 0.78 means no cancer. Okay, that's how we classify. Right? So ROC curve is not just used to measure the accuracy, it is also used to choose a cutoff point. Right? That's the point that I was driving. No, with the code, I'm not sure. I have not tried out that sure. Maybe yes, maybe no, but it's based on intuition. Yeah, it's based on intuition. All right. So I would rather stop here. Assume that this is your part one of the training. Part two, you'll be notified on when the session is going to happen. Right. Yep. Now I'm open to taking your questions. Yes, Ahmed. Please unmute yourself and then you can speak.
Yeah, sir. Like 0.921 you said, right?
Zero
So
point
0.921. So 0.9 is the cutoff, right?
zero
Means
point.
our model is predicting from 0.9, so that is outstanding.
Yeah. Yes. Yeah. If you're speaking about this, right? Yes.
Yes.
That means
Okay.
your this blue curve would be somewhere like that. 80% of the region will be under the curve. 80% of the region will be under the curve. Yeah, that's the meaning of this. If it is zero point 0.9, no, sorry, if it's 0.9, 90% of the area will be under the curve. Right.
Okay. Thank you.
Yep, absolutely. All right, friends. If you have any questions, please ask me. If you have no questions, and thank you so much. You all will be receiving notification about the next session, which will happen pretty soon for another hour. And then all these recorded videos will be shared with you all. Yeah, we will continue in the next session from here. Enjoy your cricket match. Thank you all. Good night. Thank you, Prakash. Yeah, Rishikesh. Thank you.
And in AI Spy also, extra person can log in, right?
Not sure who's speaking here. Ahmed, yeah.
Yeah. Yes, sir.
Sure,
Ahmed.
sure. Yes, certainly. Yes. Absolutely.
Thank you.
We will all, you all will be notified once the system is up and you can experience artificial intelligence in learning, in education space. Thank you all, friends. Bye. Good night.